Okay, so we're looking at day 3 of our study guide. Number 1 says f of x equals x minus 2 squared plus 4. All right, and this is saying what is the parent function and describe the transformation. So this is in the x squared family, the quadratic family, and this minus 2 means we're shifting to the right 2, and we're shifting up 4. So our graph would look to the right 2, and it would be up 4 units. That would be the vertex of this parabola. Okay, number 2. So if we're looking at number 2, this says f of x has a negative in front of the parentheses. All right, looks like that has a cubed on the end. Okay, so we are in the cubic family. So x to the 3rd power family. Remember, those graphs look like this. Okay, and the shift at minus 3 takes us to the right 3 and down 1 for the minus 1 on the end. So my cubic, all right, is going to go to the right 3, down 1. That's going to be the middle of that curve there. It's going to look something like that, except ours is negative, so that means it's going to get flipped. So it should go this way. All right, that negative in front flips everything around. All right, so that negative in front on our quadratic, if this were to have a negative like that, our graph would have gone down like a frown. Okay, so the same thing applies with these cubics, except you just have to switch the side on that. Okay, number 3, square root of x plus 1 plus 4. All right, the family for this is the square root of x, which starts at 0 and goes off to one side right here in the positive domain. There is not negatives in the domain for the square root. And our graph goes left 1 unit and up 4 units. So your graph ought to look like left 1, so over here at negative 1, and up 4. So up here at 4, that's where your beginning point is, and we're still going off to the right in that direction. Okay, let's look at number 4. Number 4 is a negative cubic. All right, I'm not going to ask you about a negative cubic. So let's look at number 5, which is the absolute value family. So the absolute value of x, which looks like a V. Okay. And this is going to tell us, this minus 3 tells us to go right 3 and down 2. So right 3 and down 2 with your vertex. So we should be at 3, negative 2, still has the same V shape there. Okay? Okay?
You skipped 4, right?
Yes. Yeah, we skipped number 4. All right, number 1 with the key features. So our graph looks something like this here. So it goes through negative 2. It's the y-intercept there. Okay. And our x's hit at negative 1 and positive 2 here. Okay. So our graph looks something like that. Okay, drawn much better on your paper than on mine. But this says, for part A, is the graph increasing or decreasing from x equals negative 2 to x equals 0? So when the graph is equal to negative 2, x is equal to negative 2, what is my graph doing? All right, and I'm tracing the graph until x equals 0, which is right here. All right, that graph is going down. So is it increasing or decreasing? It's decreasing there on that interval. Part B, is the graph increasing or decreasing on the interval from 2 to 3? So on the interval from 2 to 3, well, here's 2. And going to 3, our graph is going up. So that is not decreasing, that would be increasing because the graph is going up there. Okay, part C asks for the x-intercept. All right, the x-intercepts are at x equals -1 and x equals +2. We could write that in our factored form as y equals x plus 1 and x minus 2. That would be our factored form that gives us those x-intercepts. All right, part D, the y-intercept here is at -2. Okay, I can tell that from the graph. Y equals -2. It's this point right here. Remember your general form of this. So your general form is going to be x squared, something, 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 and then it's going to have -2 on the end. All right, so general form will always have that on the end. If you were to multiply out our x squared, right, so it'd be like x times x is x squared. All right, minus 2x plus 1x minus 2. So this would actually give you a minus x in the middle. So what multiplies to give you -2, that adds to give you -1. Those numbers are -2 and +1. -2 times +1 is -2. -2 plus 1 is -1. Okay, so everything all goes together. All right, for E, what is f at 1? Okay, f at 1. So we can look at our graph here, right? Or we could take this, either one of these, right? F at 1, and what is that value? Okay, so we can plug this in. All right, let's plug this in. So 1 plus 1, 1 minus 2. Well, that's 2 times -1. So we get -2 is the value at f of 1. And it kind of makes sense. It's going to be the same exact, right, if I had my graph drawn to scale there. Okay, part F. Okay, my maximum here. Our graph does not have a maximum. Okay, there is no point where it's increasing and then goes to decreasing. Okay, my graph is not does not look like a mountain right here. It's actually up like a cup. Okay, it's not down like a frown. So ours has a minimum though. Okay, and the minimum is going to be at that vertex. Okay, and we've talked about how to find that minimum. It's in the middle of those points. I know we've talked about finding the minimum on our graphing calculator. All right, so I'm just going to put graphing calculator to find that point. Okay, wherever the vertex is, this point right here, that is our minimum. Okay, you will be able to see what those points are from your graph on your exam. Okay, H, your domain. Domain is all of the x values on the graph. Okay, because our x values have arrows on the end here, all right, this is telling us that our domain is going to be all real numbers. So all real numbers. Okay, our range. All right, so our range is the y values here. All right, so our y values are going to be everything above the minimum for this graph. So whatever the y value is here for the minimum, okay, it's going to be below -2. All right, whatever this minimum may be, it's everything above that. All right, so let's just say that minimum is at -2.5. So y is greater than or equal to -2.5. Wherever this minimum y value is where it's going to be. Okay, it's going to be above that. All right, and then lastly, is my function even, odd, or neither? Well, that function is actually neither. Remember, your even functions are symmetrical, all right, symmetrical over the y-axis. So your graph, here's the y-axis. Okay, any parabola like this could be like a W, right? Let's see if I can make that work. All right, symmetrical over the y-axis. That would be even. Odd, the thing to look for odd is it goes through the origin. So symmetrical over the origin, okay, or over 0. So, for example, the x to the third, okay, like that. X to the third is symmetrical over that origin. So it's the exact same graph on either side of the origin point. Okay, and if it doesn't have either of those features, it is neither. That's why our graph here is neither. It is not symmetrical over the y-axis because of the shift here. All right, because of this shift. It's also not symmetrical through the origin there.